Welcome to Silicon Valley Buzz, the show where we discuss happenings in this, the most fertile spot on the planet for new ideas. I'm Seth Shostak, your host. The producer is Janet Wu. Science. That's the occupation of white lab-coated types, right? Highly educated, exquisitely trained guys in tweed jackets working at some academic institution. Well, tonight we're going to open science to everyone, right? Science, not that you just have to read about it, but that you can do it. My guest is a research affiliate at the Institute for the Future in Palo Alto, and also the founder of Spacehack.org, Ariel Waldman. Ariel, welcome to Silicon Valley Buzz.
Thanks for having me.
All right, science. I mean, that's a relatively new job description. A couple hundred years ago, you couldn't be a scientist, or if you were, they didn't call you that. I think William Wheel invented the term in 1833. And, being a scientist suddenly was something you could be, but it was still restricted mostly to amateurs. They were just sort of men of leisure in Europe who would do a little bit of science on the side. But then the 20th century comes along and suddenly it's a profession and you have to have a PhD and all that stuff to do science. Do you think the pendulum is swinging back? Are we going to see citizen science now?
I definitely think we are going to. I think we're in the midst of a citizen science renaissance, and over the next few years and decades, we're going to see this emerge even more. I think a lot of science, as you said, has been run by amateurs, people who would be considered amateurs by today's standards. But over the last few decades, technology became so expensive, and a lot of infighting in science led to people debating about who's considered an amateur and who's considered a professional, which is healthy sometimes, but a lot of times it really creates an environment in which being an amateur isn't something that's to be desired. And unless you're actually working for a government agency or a university, you often don't have access to the technology that you need to make accurate measurements. And so we've kind of come up amongst this sort of elite science age, but I think you're starting to see people breaking through as technologies are becoming cheaper and different types of communities are forming around how you can do science without having a formal science background. So I think we're definitely seeing the pendulum swing back to an age where anyone can do science.
Well, but does that make any sense? I mean, can they really do science? Because in astronomy, we've always had amateurs doing astronomy, the worthwhile astronomy, finding comets, monitoring variable stars, whatever, astronomy, but not in physics. We didn't have people trying to imitate the kind of results you could get with a Large Hadron Collider. So can people really do science that's more than just hobbyism?
Definitely. You're seeing a lot of different projects emerge in which people can actively contribute to scientific discovery, things where they can actively discover new galaxies that haven't been discovered before or create new algorithms for finding dark matter. And all of these different projects are creating sort of unexpected solutions in which, by having open collaboration and having a lot of different people working on these projects, you are getting new solutions that you otherwise might not get from science, from the scientific industry, where everything's very closed off still. And so you have all these different ways of sending robots to the moon or analyzing extraterrestrial intelligence over radio signal data, potential extraterrestrial intelligence.
Well, tell me about that, sending satellites to the moon. I mean, how could I do that as an amateur? How do I do that?
There's projects like the Google Lunar X Prize, which is a $30 million competition to build and send a robot to the moon. And you've already got international teams from all over who are doing this and sending their robots to the moon.
Well, but they're building the robots, not building the rockets.
They're building the robots. A few of them are actually building the rockets. I don't know exactly how the progress is going because it seems like a pretty big task to build a robot and build a rocket. But you have all these different teams, and they're not government agencies, and they not only need help from people who have engineering skills, but they also need help from people who are good community managers, good at editing blogs, people who can help make their mission a success in all of these different ways. And so they're really needing help from all different types of people. There's also other competitions like the University Rover Challenge, which is trying to build the next wave of Mars rovers. And they not only need their Mars rovers to explore the surface of Mars, but potentially also save human astronauts in distress, because if and when we go to Mars, we might actually have astronauts who are needing help, and it would be great to have a robot counterpart who could help them.
A St. Bernard robot kind of thing. Well,
yeah.
What if I'm interested in biology? I mean, Can I do amateur biology experiments?
There's a lot happening in DIY biology. There's bio garages happening all over the United States. There's actually one in Sunnyvale called BioCurious, where it's really a hacker space for people who are interested in learning about biology, people who are already involved in biology, to learn about it and create experiments and do a bunch of really interesting work. There's a really great technology that that some of them use called OpenPCR, in which you can start to analyze what your food is made of and start realizing if your sushi has been genetically modified. So there's a bunch of really great experiments happening at these bio garages all around.
I think that I've read about people doing, this is calling, was it biopunks that they're occasionally called? I've seen that term. Yeah, and that they'll go in and they'll set themselves a goal of developing, I don't know, some sort of single-celled organism that glows green or something like that. What sort of things could they do? I mean, you've mentioned some, but give me a specific example of something that I could do in this bio garage that that the professionals haven't already done.
Being able to actually analyze different foods based on the DNA and makeup of it is really interesting, actually, and working with OpenPCR, because the OpenPCR machine is about this large.
Maybe you should explain what a PCR, what it stands for.
Well, a PCR, actually, I can't remember. That's a horrible thing to ask me, since I'm not a bio person. But it's a machine that's about this big, and you can analyze all these different things through it. And the great thing about it is that it's actually cheaper than a lot of the DIY 3D printers. So I think the going rate for them is $500. So again, these things, these machines in which you can do these bio experiments are actually becoming really more accessible for everyday people to start using. And I think the more exciting part isn't necessarily what experiments can you do with it, it's what experiments haven't been done with it yet, and how can you start being more of a pioneer in this new frontier of DIY biology. I think that's what a lot of people are actually excited about and waiting for, is to see what new things people can do with this.
If I buy one of these PCRs, whatever they are, can I take it to my local fast food emporium and check it out and see if any of that food is worth eating?
I think you could. I've heard stories of people doing that.
Well, I want to ask you about my own field of astronomy and the Galaxy Zoo, and how ordinary people can find entirely new classes of objects in space. But first, we're going to take a break, and we'll be back with Silicon Valley Buzz right away.
Unlike commercial or public TV stations, we at KMVT Community Television focus on Silicon Valley residents, organizations, and businesses. We televise to over 100,000 viewers in Santa Clara County, with syndication potential to more than 1 million in the greater San Francisco Bay Area. We at KMVT connect Silicon Valley communities, empower people, and effect change. Do you?
Welcome back to Silicon Valley Buzz. I'm Seth Shostak. My guest is Ariel Waldman, the founder of Spacehack.org, right? And also a researcher at the Institute for the Future, an affiliate researcher at the Institute for the Future, right here in Palo Alto, or right there in Palo Alto. In my own field, I know that there's a project called the Galaxy Zoo. And the very idea of putting galaxies behind bars is interesting enough. I have to tell you that I don't quite understand what the Galaxy Zoo does, so tell me.
Galaxy Zoo is essentially an online interface in which people can classify and potentially even discover new galaxies that haven't been discovered before. And so it's an interface in which you get a pretty picture of a galaxy, and it asks you some basic questions like, is the galaxy a spiral or an elliptical? It has a fairly low learning curve, so it's something that really anyone can get involved in, and you can start classifying things. But the really interesting thing about Galaxy Zoo is that you can investigate the data behind the galaxies. So if you look at a galaxy and it looks a little bit strange to you, you can actually start investigating it, and that's how people are discovering new galaxies that haven't been discovered before through it.
Okay, so I do this at home, right? At the privacy of my own home, I fire up my computer and I go to Galaxy Zoo and I sign up, and then they start sending me pictures of galaxies.
They don't send you pictures of galaxies. You can access them through the website, and there's all these different great features that has where you can even favorite galaxies. So if you come across a galaxy and you want to come back to it again, you can mark it as a favorite, and there's a lot of really space geeky features like that. But the great thing is also the community behind it, because you can start collaborating with people to figure out what different types of galaxies you're looking at are. And in the case of the green peas galaxies, which were entirely discovered by Galaxy Zoo members, they discovered these peculiar looking galaxies, and they started collaborating with people on the forums to try and figure out what they were. And some people with science backgrounds and some people without science backgrounds were trying to figure out what they were, and they ended up discovering one of the most efficient star-forming galaxies that have been discovered before.
Maybe we should explain that a little bit. Green peas, not Greenpeace, but green pea galaxies, because they look like a little green pea on the photos.
Yeah, they look like a little green pea, and I believe they were found because the robots or the data behind Galaxy Zoo had marked it as a star, but when someone looked at the spectrum data for it, it didn't match the spectrum data for a star, and hence it seemed a little peculiar, so they started investigating behind it, and they found out all these different galaxies, and all of this is really great also because it leads to better machine learning, so the robots can start getting better at classifying these galaxies in addition to the humans, and hopefully the robots then won't overtake us since we've taught them so many great skills.
Well, that's okay. They don't require coffee breaks. You know, if I'm interested in science and I live here in the South Bay, for example, you know, and somebody said, so, but I'm not trained, you know, I fill out tax forms or whatever. I don't do anything in science professionally. If they'd ask me, well, what can I do to get involved in science? I would say, well, take out a subscription to Scientific American or something like that. What would you tell them today?
I would tell them to get started on Galaxy Zoo. It's the easiest way. You can sign up in 2 minutes, and within 2 minutes of right now, you can actually start potentially discovering new galaxies. There's also other great projects like Planet Hunters, which are looking for new exoplanets that haven't been discovered yet. Also, going to the BioCurious lab in Sunnyvale is also a great way to get started. People are happy to tell you not only how to learn different biology stuff, but if you're also interested in having biology as a new career, people are there to help train you and teach you how to do that.
I have to also mention there's something called SETI Quest, which is in my own field of SETI, in fact, where people can go in there and they can look at data taken with radio telescopes and see strange patterns in the data which they can classify, because your eye is very good at classifying things in a way that computers, you know, aren't yet. So anybody who's interested in maybe helping us find ET, that's SETI Quest. How did you get involved in this? What interested you in the beginning in this? Because you didn't study science, did you?
No, I don't have a scientific background whatsoever. My degree is in graphic design, and I had worked at an ad agency for a number of years. How I came into my new science role in my life is I was watching a documentary called When We Left Earth. It showed on the Discovery Channel in 2008, I think, and it was about the NASA program over the last few decades. And I was so excited and inspired by it that I decided it would be so awesome to work at NASA. But obviously I had no idea if they ever needed someone like me, so I sent them a shot in the dark email saying that I was a huge fan of what they were doing, and if they ever needed a volunteer, I was here. And serendipitously, I was able to get a job at NASA off of that email, and it changed my life forever, because you can't really work at NASA and then not work in space exploration again. You can't really say, oh, that's just a job I had once. It really changed me, and it really inspired me to promote this to other people, that despite not having a scientific background, that you can actively start contributing to space exploration and science, and that the science industry actually needs people from all different areas in order to really help them.
One of the things on your business card, Ariel, is you are the founder of Spacehack.org. Tell me what Spacehack.org is. It's actually not Spacehack, is it? It's Science Hack.
Spacehack.org.
Oh, it is Spacehack. Okay, good.
I haven't made Science Hack yet. But,
Oh, is that coming?
it's coming, yeah, sciencehack.org. I've got the domain. But Spacehack.org is essentially a directory of ways to participate in space exploration. So all of these different projects in which you can send robots to the moon or find new galaxies, those are all documented on Spacehack.org. And I really created it in a couple of weeks after I left NASA because I had heard about all these great ways in which people could actively contribute, but they were either buried deep in government websites or difficult to understand.
You mean the data were buried deep?
The data was very deep, and some of the projects themselves just weren't really promoted outside of the scientific industry very much. And so Spacehack kind of documents these and in 2 or 3 paragraphs says why you should care, what you'll be contributing to, why it matters.
Okay, so I could go to the spacehack.org website and I would find a menu of activities.
Yes.
Do you have any activities where people actually come together?
Yeah, there's all different kinds of activities, some of which are events. I would argue that the ones in which you're building a rover, you inherently need to work in person with those people. But there's also events that can help get you involved. There's the annual Yuri's Night event, which gets space enthusiasts together. But the great thing about it is that Yuri's Night also tries to get people involved in space exploration. So a lot of times at these Yuri's Night events, which happen all over the world, you have scientists and different types of people there who can tell you how you can get more involved, and you get access to all those people in person.
You brought a bit of video from a Spacehack event, did you not?
A Science Hack Day event.
Science Hack Day. And where was that held?
The Science Hack Day event last year was held in Palo Alto at Institute for the Future.
Okay, and you brought people together to do what?
We brought people together to just get excited and make amazing things with science. And this really ranges from anything from high altitude balloons that map the Earth below to someone built a particle wind chime, which takes particle collision data and maps it to sounds. So you could actually hear what a particle collision might sound like.
Did you determine the projects in advance, or did they come in and volunteer, like, I'd like to do this, I'd like to do that?
Everyone comes in and volunteers. You're welcome to show up with an idea before the event, or you're also welcome to show up and not have any clue of what you're going to work on yet. It's really, a lot of it's about eavesdropping and collaborating with all different types of people, developers, designers, scientists, roboticists, marketers, all different types of people, and just to get excited and make things with science. And it can be anything that's serious or anything that's silly. We don't really tell people what they have to work on.
Well, maybe we could run that video and take a peek at what Science Hack Day looked like.
Definitely. Ideally, it's really about creating a spark. It's really bridging the gap between scientists, developers, designers, robot builders, community strategists, just people who have good ideas in general who want to come and hack. There's so much value out of coming together to actually build things as opposed to just talk about things. Not that there's not value in that, but being able to prototype things, I feel, can communicate and actually affect change that much faster. Science Hack Day is officially kicked off, and start hacking.
Jeremy and Ariel described the sort of web community and the science community as having this really big overlap in interests and passions is completely true, but they've existed in isolation before.
Having an event like this really brings together a community of people who care about making this crossover and making just awesome things over a weekend.
The San Francisco Hack Day looks fantastic. I mean, the level of creativity here seems to have been kicked up a notch.
We've talked to someone who wants to hear what the Higgs boson sounds like. Someone sitting right next to you is trying to get launched into space. Lots of really cool, interesting people. It's a blast.
The key thing in a place during a hackathon is the right environment, the right culture, having lots of food, but really good people.
It's really great because it's just invigorating to overhear what people are talking about and sort of peer over the shoulders of people and see what they're working on.
I've never been involved in a hack day of any type, so this was a great initiation to the whole process.
Science Hack Day has wildly exceeded my expectations.
People are like hacking away, and like one person's having an issue here, like, oh, I got a piece that'll help you with that, and it's just really amazing to see like all these like different people come together for a common goal.
There's such a diversity of interests and talents of the people that have come here that very rapidly we've been able to ramp up into a 3-4 person project.
I'd actually been interested in doing something like this for a while, but never really had a venue for it, and it's better to do things with other people.
This is just a fantastic event because I get to meet a lot more creative people who want to do things with science.
Come with a plan.
Anything can happen.
I walked into the other room and I heard a positron and an electron collide and annihilate each other into other subatomic particles.
This is the second event of its type, so hopefully it'll sort of encourage that this can happen in any city, and it'll start catching on from there.
Science Hack Day is awesome.
Yeah, it's just fun. I think I'm going to definitely impress my kids.
Well, sure looks like a lot of fun. You know, I've had the impression for a while that the younger generation is interested in computers, you know, writing code, hacking digital electronics and stuff like that, but not so much interested in, if you will, basic sciences like, you know, mathematics or chemistry or physics or something like that. But it doesn't seem to be the case. They were talking about, you know, elementary particles there and stuff like that.
Yeah, I think that's one of the main reasons for bringing Science Hack Day to Silicon Valley is because you have the science and technology industries here, and they are enamored with each other, but they don't really talk to each other. They're kind of two different types at a dance party, kind of standing on the edges. And it's really interesting because if you take a group of NASA engineers and you give them a tour of Google, they're like, oh my God, I'm at Google, this is so awesome. And equally, you have everyone at Google going like, oh my God, there's people from NASA here. And so there's this total excitement for one another, but just socially and just industry-wise, you don't really see much crossover, and it doesn't really make a lot of sense to me. So one of the main motivations for Science Hack Day in Silicon Valley is really to get these people in the same room because they are totally excited by one another. And so getting scientists to work with technologists and getting technologists to work with scientists is really exciting for both. And I think it's just a matter of giving people more access, more in-person access. That's really the only dividing line right now.
Let me switch gears a little bit, Ariel, because you know, part of your job is to work at the Institute for the Future in Palo Alto. The Institute for the Future, in a sense, I guess all institutes are looking toward the future, right? I mean, so what does the Institute for the Future do? It sounds very idealistic.
Institute for the Future is a nonprofit organization, and essentially kind of a think tank that's existed for 43 years, which is a really long time for thinking about the future. But it's a really great organization that forecasts usually about 10 years out about what might be happening in the future. Not predictions, but forecasts. What are the movements? How is the landscape changing? What are the big drivers going to be? What are the big stories that we're going to see emerging over the next 10 years?
But does this have mostly to do with projected trends in technology or science, or, I don't know, I mean, for that matter, the environment? Do they worry about the effects of climate change?
Institute for the Future actually tackles most of those things. So we think about technologies, we think about how the global climate is changing, we think about what the food outlook looks like over the next 10 years often. So it really ranges from anywhere from technology, science, food health, to really a global picture. And we do energy work and things focusing on kids' technology. It really changes. There's a lot of different projects happening, and it's really interesting to see the crossovers between these different subjects each year.
And so how does it work? I mean, is it really a think tank in the sense that if I were to walk around the Institute for the Future on, you know, a random afternoon, would I just see a bunch of very smart people sitting in offices thinking about things?
You would definitely see that. You would also see people doing active research and having expert workshops and different ways of engaging people, and not only having people think from within the institution, but also getting people from outside to think about the future. I think one of the things that Institute for the Future really strives for is to have a great social impact. And a lot of that comes from getting people just to think about the future and knowing how to think about it and figuring out how that might be able to solve different things that they're dealing with in the present.
What's the product of the Institute? I mean, is it, do they produce papers or, you know, reports? What, you know, they've done this thinking. They've given a lot of, you know, time to that. where does it go?
Institute for the Future has a wide variety of deliverables, some of which are reports. There are yearly programs in which people can be subscribers to, so they can actually subscribe to what Institute for the Future is focusing on year after year. There's also custom work, so that we are developing maps and different navigational items to sort of walk someone through what we forecast is happening in the next 10 years.
Sort of a technology landscape of 10 years down the road?
Right, exactly, a technology landscape. And a lot of times we also focus on doing games and things in which we have a massive amount of participants forecasting what the future looks like, and we're able to pull out a lot of insights from that.
And has this made a difference? Can you cite an example where the Institute for the Future's work has actually changed how society functions?
Definitely. There's a lot of different instances for it. On the client side, P&G is one of Institute for the Future's sponsors, and P&G over the years has been able to create an innovation lab thanks to Institute for the Future.
When you say P&G, you mean Procter & Gamble?
Procter & Gamble,
yep.
Right. And so it's interesting with Institute for the Future because there's a lot of social impacts that we're trying to drive about getting companies to think about how food might become scarce in the next 10 years and how they can help that. But also with the sponsor side and getting them within their organization to think about the future and really help drive how they can align with different things that are emerging.
That's fantastic. Well, unfortunately, our future for the rest of the show is rather short. We've come to the end of the program. Ariel, if you had to predict what the scientists of the future are going to be like, any different than the scientists of today, very quickly?
Definitely going to be a lot different. They're going to be really data-enabled, collaboration-enabled people who don't really have boundaries anymore, and really leads to a lot of open, exciting work.
Well, that does sound exciting. I mean, the availability of opening up the data sets sounds good to me. Ariel Waldman, thank you so much for spending some of your time here so we can have a better idea of the future. And as always, thanks to our hardworking KMVT staff, future-looking, I might say, and our producer, Janet Wu. I'm Seth Shostak for Silicon Valley Buzz, and I hope you'll join us next month for another exciting story of what's going on right around you here in the most exciting, innovative place in the world.